There you go.
Can I have some of that water?
Lab 2.
Can I have some of that water?
Hi, Chem students. So today I have helpers. I've got Jewel and Troy, my kids, gonna help us investigate 13 different things today. And your goal is to just identify if it's a physical change or a chemical change. We're just gonna go through all 13 super quick for you. This is lab investigation number 1. So keep in mind, is it physical or chemical? Go ahead, Joel, show them the first ones. Real basic. What are they doing?
Cutting the paper in half.
So as they cut the paper, is this a physical or a chemical change? Keep cutting.
Okay, what? How?
Smaller.
Like what? Like that?
Just keep doing it, yeah. And then maybe I'm tearing. Okay? All right, pause. Okay, lab investigation number 2. I also want you guys noting qualitative and quantitative data every single time. So that means quality. Troy, Jewel, what does this look like?
Piece of paper.
What color is it?
White.
Okay, so white paper. Then, here we go. What are we seeing happen?
Turn into brown.
Okay, we're good. Go ahead and show them. Logan, my son, is doing the video. What color? Qualitative. What do you guys think?
Brown and black charred.
Ooh, you're all right. Okay, there you go.
Can I have some of that water?
Lab 2.
Can I have some of that water?
Investigation number 3. Is it a physical change or a chemical change? Remember, qualitative data here, please, people. So Jewel has vinegar. She's going to put 10 drops of vinegar into the test tube, please, Jewel. Troy has ammonia, which is basically Windex cleaning. And so he's going to put 10 drops of Windex ammonia into his test tube right now. Go ahead. What I have here is a universal indicator. And I don't know if you guys remember doing some of this with ocean acidification and bromomethyl blue. But these are the things, or the cabbage juice that you guys did, they change colors when they're in different pH. Remember pH, is it an acid or is it a base? I don't know if you remember that lab, but this color chart will tell us whether or not we have an acid. Okay, hold on one second. Acid will be a pH below 7, and it will be a red, orange, or yellow color. If we have it neutral, like water, it'll have a pH 7, it'll be green. If we have a base, it will be like turquoise to bluish to purplish color. That's a base, all right? And so right now, we're gonna test both of these and see which one's what. So
10.
let's go ahead and put, Jewel has vinegar.
10 vinegar.
I'm gonna put 1 drop in. Okay, what color did it turn?
Red.
So is that a acid, neutral, or base? What do you think, Joel? What color does it match?
That is this one.
So that's an acid, okay? Now, let's do Troy's. He's got the vinegar, or not, I'm sorry, the ammonia household cleaner, Windex.
Purple.
Hold on. And what color is his? Put it in the light.
Purple.
So is that an acid, neutral, or base?
Mine's like I like mine. This one.
A base with pH of 10. Joel, yours was red. That's like a pH of 4. Okay, so what do you think, guys? Is that chemical or physical change? Okay. Okay, chem students, we're on lab investigation number 4 now. What we're going to do is the same exact thing they had in 3. Jewel has her vinegar, which is pink and acidic. Troy has his blue ammonia Windex, which is a base. They're now going to mix it, and we're going to look at the color to see what happens. Go ahead. Okay, so we're going to have to stir it up.
Orange.
Okay, I think we need a little bit more. It's still a little red. We were supposed to have an equal amount of each.
Wait,
Troy, can you put a little bit more vinegar in there and see what happens?
In here?
Yeah. I think,
Vinegar or?
yeah, couple, or I'm sorry, ammonia. Go ahead and put a couple more. We were supposed to have equal. Go ahead and stop. We're just supposed to have an equal amount. Okay, there we go.
green.
So I don't know if you can see that.
That's green.
Wait, let's do a couple, a little bit more of the ammonia.
Vinegar.
Or I'm sorry, vinegar. Good thing I have you guys. I wouldn't know what I was doing. All right, there we go. We're just trying to get, like Jill said, we're trying to get green, okay? Okay. Well, now it's too much.
No, it's too much, Mama.
Now I'm
Yeah,
going to put
great
more
job.
of the ammonia. Windex.
I was kind of getting
Oh, let's just, there it is, right there. Okay. So, can you guys see that?
That's green.
Green.
Green,
Okay.
yeah!
So now it's neutral. pH 7. What type is it? Chemical, physical? Miss, let's wrap up what we just did real quick before moving on. I want you to remember that if it's an acid, it has a high H plus ion concentration, making it more acidic. That's why the pH is below 7. 0 to 7, sometimes negative. If you're neutral, then you have just as much H plus as OH. Combine, make water, right? That is neutral, pH 7. Last, if we have bases like cleaners, then we have a pH that is above 7, okay? We've got a little bit more of that OH ion, the hydroxide ion, that causes it to be more basic. That's just a recap from investigation 4. Now moving on to investigation 5. Here we have something that's called cupric sulfate pentahydrate. Hydrates are things that have water on the structure of the molecule because, you know, some things just love water. So Jewel, show them the pretty blue crystals of cupric sulfate pentahydrate. She's going to do lab investigation 5 right now. So go ahead. That's enough. Close it up. Troy is going to show you this next part where he's taking a mortar and pestle and go ahead and start crushing it. Do it on the table. This doesn't come out. All right, so this is lab investigation 5. While he's doing that, remember, qualitative. What did those crystals look like? What was their size, color, all of that? Then is it a physical or chemical change, what we're doing right now? And as soon as he gets that all, pound it a little bit more. Just,
Like do this.
there you go. And then scrape it. Okay, go ahead and pound it some more. Okay, go ahead and show them really quick. All right, we could keep going, but here we have crushing.
Can I do it?
What does it look like now? Qualitative. Look inside there.
Can I do it?
No, not right now, Joel. And
Okay.
see what the sizes are. Okay. Really quick, guys, I just wanted to show you when it's crushed up what it looks like. Okay. Students, we're on investigation number 6 now, and we're still using that same copper sulfate pentahydrate blue powder that we just ground up. But this time we're going to heat it. So we're going to say what happens after heating. This time we're going to get actual quantitative data, which means number. Okay, so we're first going to figure out what the mass of the crucible is when it's empty. There's nothing in here right now. So Troy, can you tell me what it says, and we're going to fill that out.
It says
Empty crucible. Just pick a number it stays on the most. And don't push on the table.
8.36 is right. It said the most. 8.36. Okay.
Let's do 8.5. Just because it seems to fluctuate. So mass of empty crucible 8.5. Then we're going to, you guys are writing that down too. So 8.5 grams. And then we're going to put some of the powder in. Joel.
Water cup.
Okay, Troy, what's that number?
It's 11 point.
11.6.
11.60.
Okay, so we're going to do some math here. We've got 11.60 grams is the crucible plus the powder minus 8.5. How much does the actual powder in there weigh? So what's 0.6 minus 0.5?
3.1.
So it's 0.1. And then 11 minus 8, 3. Correct, Troy. 3.1. He said it faster, sorry. Okay, so we have powder before heating of 3.1 grams. And also we're going to write down the color. It's blue. Okay, so
Blue is BL.
that's where we're starting. I'm now going to heat this and I'm going to see what happens. All right, students, we're on investigation number 6 right now. We let this copper sulfate pentahydrate heat, and we already collected the data. It was blue powder before, and it had a mass of 3.1 grams. Now we're going to see after heating what the color of the powder is and how much mass it weighs. Qualitative, quantitative data. Get this in your notebooks. All right, let's do this.
Wait.
Okay. Tell me when.
You could go now.
All right, so right now we're going to go ahead and take the lid off. What color is it? Joel, what color is it?
White.
It's white now, not blue. So we're going to fill that out with white. Then we're going to weigh how much it weighs. Turning this off. Troy, you're going to help me out with how much it weighs. What's the mass?
10.47.
So 10.47. So we're putting 10.47 grams, and you can help me with the math, Troy, or math. What's 10.47 minus 8.5?
It is 1.93.
1.93. Okay, so it weighs 1.93 grams now, and it's white. Put that side by side with the before heating. So 3 grams before heating, 1.93 grams. Is that a physical or a chemical reaction? Also, I want to point out that this had a H2O. It was a pentahydrate. And after heating, this H2O, the 5H2O, is no longer there. So that's why we ended up with less mass. We cooked it off, and it's now just copper sulfate, okay? The hydrate disappeared as steam. So is that a physical or a chemical change? Sounds real easy. Investigation number 7, we're gonna look at some candles here and wax. Okay, 7, we're gonna look at what the color, write down in your notebook what the color of the wax is. What color is that?
White.
White. Okay, then we're gonna heat it a little bit and we're gonna see what it changes. Now, just to save time, I've already preheated.
It's gonna go to brown, guys. Let's see.
It's not brown. Troy, can you look and see?
I can't
Come here with the camera.
It's
What does the wax turn into?
A
Not
liquid.
only is it, yeah,
Sounds like
exactly,
birthday
Troy.
cake.
It also turns into a liquid. So after heating, that wax, which is
Smells like
solid,
birthday cake.
becomes a liquid, and the liquid becomes clear. You see that?
You stop, Troy.
So you see the wax melting. So that is 7.
It smells like vanilla
What?
cake.
Yeah, it's a vanilla candle. So see it disappearing right there? You see it? Okay. Now, is that physical or chemical? Go ahead and pause. Really quick, this
smells
one's
really
super
good,
easy.
guys.
Investigation number 8, physical or chemical. We're going to look at the wick. What color is it? White. Okay. Then we're going to light it. So it's white. Jewel, get off of me. We're going to light it. Get in close, Logan. What color is the wick when it's lit? Brown. Chemical or
I told you
physical?
guys it was gonna be brown. On
That's
number
it. We're going to do investigation 9 and 10 together. What we have here is baking soda powder, and then Troy has baking soda solution. That means water's added and it's watered down. Jules got vinegar. So again, physical, chemical, and appearance, qualitative stuff. So let's go ahead and do some powder there. Jewel, go ahead and put the vinegar on top of it.
how much?
Just squirt it all over. Can you get that? What do we see happening? Qualitative data. What do you see?
Bubbling.
So what state of matter is bubbling? Solid, liquid, or gas?
Okay.
Gas, right. So the bubbling is a gas, so it went from a solid white powder and a clear liquid into bubbling gas. All right, now you're gonna put your baking soda over here, Troy. So that was 9. Now investigation 10. This is watered down baking soda. Go ahead and squirt a bunch squirt it fast.
Can I touch it?
Okay, camera, I think you're gonna need to zoom in here. No, come over here. You're gonna squirt vinegar in there now, Joel. Compare in the amount. Yeah. Can you hold back a little bit so the camera can get in? Go ahead and add. Do you see that? Go ahead and add some more.
Bubbling.
You see bubbles? How much?
Like,
Do you see that, camera? Go ahead, add some more. Almost looks like a soda, doesn't it? Like a little fizzy soda? Okay, that's investigation 10. But those are both liquid still, but then these bubbles come out of that. So that's your qualitative. All right, 9 and 10. On 11, we're going to add, Jules going to add, go ahead, 10 drops of baking soda solution that we just used in investigation 910. So watered down baking soda. And then Troy is going to add some silver nitrate. And the silver nitrate's is stuff that can turn your hands brown that we used in our last lab. But
10.
qualitative data, put it up for the cameras to see. What color? What does that look like? Can you describe it, Joel?
It is clear.
And is it a solid, liquid, or gas?
It's got
What?
solid liquid.
Liquid. There you go.
Yeah.
So clear liquid. Now Troy, go ahead and give that to Troy. Hand it off, or I'll hold it for you if you want. Go ahead and drip 10 drops in there. Are you getting that, Logan?
Mm-hmm.
Boom. Okay, we're good. What happened?
It turned a solid.
It turned into a solid, right. And what color is it?
It's like white.
It's a white solid inside of a clear
It's a green.
liquid.
No, it's a white.
So, well, it looks white with maybe a tint of like yellowish, I think. All right, number 11, guys. Physical or chemical? Investigation number 12. What we're going to do is compare what's inside of pre-1982 pennies, and I want you guys to write down the color of those. And then what's inside of post-1982 pennies, and what's the color of those. So how would you describe the difference between pre and post, Joel, since you're over there? Move. What do they look like? What's the difference in the pennies?
This one's white and this one's dark.
Right, so this is like a copper penny that's dull, where this one is shiny. So let's go ahead and see what's inside these things. And is that a physical change or a chemical change? Like what property is making them change? Okay, so first thing we're gonna do is we're gonna have to do the mass of the pennies because we're gonna look at the density.
She's rich,
Density
guys.
is a physical property of the matter to tell you like what type of element is inside of it, or maybe what type of chemical. So Troy, you're gonna help me out here. We're gonna say how much these 10 pre-1982 pennies weigh. Go ahead and tell me, and I'm gonna put the data right over here.
These are 30.83 or 83. Yeah.
So those are 30.83 grams. Okay. And then we're gonna calculate the volume of those 10 pennies. So we have, when you have to do the volume of something, which is length times width times height, that's volume. And you can't exactly measure all these pennies because they're regular shape. You use the displacement of water. So I've got 50 mils of water in here, and I'm just gonna plop them in. Oops. And then we're gonna measure, you get eye level, look from the bottom of the U-shaped meniscus, it's 50, 51, 52, 53, 54, like almost dead on. So it's 54 milliliters. So what's 54 milliliters minus 50? It's like 0.0 on both. They were pretty spot on. 4 milliliters. So it's, we gotta do density, so it's 30.84 divided by, or sorry, 30.83 divided by 4. Let's do the math real quick on that. So let's get our calculators out.
Calculator in our pocket!
So
That's cool.
30.83.
Cool.
30.83 divided by 4 is 7.7, which is fine for the density of
They're
that.
copying each other.
Okay, now we're gonna go ahead and do the mass, Troy, of the post. Oops, can you pick that up? Post 1982 pennies. So tell me what those are.
24.
It was like 25, Joel. No.
No.
Okay, it was 25. Joel, can you please don't mess up our scientific data? 25 grams. And then we'll go ahead and
Guys, look how cool these
dump
are.
out that water here.
Hey, don't hit me in the head with your glasses. Guys,
What was it?
look
Can you
how
count
cool
to make
these
sure there's
are.
10 in there? Look, Troy.
In here?
Yeah. Is there 10 on there?
They're so cool. They're like painted. Whoa, it's a roasting. Mama, something happened.
It's just water.
Yeah, there's 10.
Okay, so can you tell me the max on that again since Joel messed it up?
Oh, it was 25.
25 still?
Well,
Wait, take your hands
that's
off.
That's what you said.
Yeah, 25. It's still fluctuating just a little bit. Okay, so we have 25 grams, and we're putting it into 50 milliliters, and then we're going to watch the rise. And so, the rise up is
Look how cool
51,
these are.
52, 53. Actually looks like 53. 1, 2, so 53 milliliters. So 53 milliliters minus 50 is 3.
Mama?
So what's 25 divided by 3? That will be the density of the pennies.
Which
you can
is
go ahead and take
5.
that. Can you do 53, or sorry,
Can I take that out, Mama?
25
Can I
divided by
take it out?
3
Can I take it out?
25.
divided by 3. Not times 3, divided by. 25,
Oh, sorry.
Okay.
25 divided by 3.
Equals
8.3.
8.3.
So
Can I
the
take
density...
these out? Can I take these out?
Yes. So the density of the post 1982 pennies, which also appears shinier, 8.3 grams per milliliter, where the older pre-1982 pennies are dull and have 7.7. So did the chemical structure or mixture of metals in these change? It appears to be what? You can answer that in your lab. Also, maybe why would we go from older pennies having a difference in newer pennies? Maybe the cost of the cent, like does the metal cost end up being too expensive and more value than the 1 cent? That might be a part of the problem just to think about, okay? All right, so that is number 12. Investigation 13, we've got some iron nails, okay? And then we're gonna put it in a test tube and I'm gonna coat it with some copper sulfate. Copper sulfate, write down qualitative data, is blue liquid. And then the iron nail was just a silver metal. And we're just gonna let it sit in this for a while and see what happens. Again, starting to rain, sorry guys, trying to hurry this up. Is this a physical or chemical change? We're gonna pause and I'm gonna come back. I'm gonna let this sit. Oh wait, actually we don't have to. It's happening right now. Okay, super cool guys. That iron nail, this is not magic, but it sort of looks like magic, so. Can you see? Let me just put it out. What happened to the iron nail? Can you zoom in? What color is it now?
It's like pink, and all the rust came off.
It went from, don't touch it please, Joel. It went from a silver nail of iron to a copper coated nail using our copper sulfate blue liquid solution. Physical or chemical change. All right,